Welcome back, and as promised, we still have this playground open right now. If you don't have this open or you left and came back, go ahead and get this file open because this is where we're going to be picking back up from. If you don't have this code anymore for whatever reason, go ahead and just pause the video. I'm going to see if I can zoom out here a little bit. Go ahead and pause the video right now and go ahead and copy what we have here because we're going to need this to kind of continue into the next lesson. Or if you just want to observe, that's fine too, but I definitely recommend following along and coding along as much as you can. That's probably how you're going to absorb the most information. So anyways, give you a second to pause and then come back. Okay, cool. Now that we're all on the same page and we've all got the same code on screen, I'm going to go ahead and zoom this back in so it's a little bit more readable. And we're going to go ahead and pick up, like I said, we're going to pick up with inheritance. That's what this video is about. And basically what inheritance is adding the ability to a class to be extended to be a little bit more specific. So what that means is, let's say we have a worker class, and that's fine, but let's say that we're designing an application, right, for like maybe a doctor's office or something. Well, a lot of our workers are going to be the same. We're going to have a lot of doctors. We're going to have a lot of, let's say, receptionists. We're going to have a lot of like nurses, maybe medical assistants or whatever. We're going to have a lot of the same types of people. So instead of having to create all these workers individually and say to every one of them that they're a doctor and their job is to heal people and their salary is the same, maybe a lot of this stuff is just the same if you're in the same position. So if we've got a lot of doctors, we don't really need to keep setting doctor and keep setting to heal people and keep setting salary over and over again if they're all going to be exactly the same. And this kind of brings me to a term that maybe you should write down or jot down in your notes or whatever, which is called dry. And we say this a lot in programming. That just means don't repeat yourself. If you notice in programming ever that you're starting to repeat yourself and you're starting to write a lot of the same code over and over again to do the same type of thing, you're probably not doing it as efficiently as possible. There's probably a better way to write that same code. That's kind of the whole premise of programming, is trying to make things run as efficiently as possible without having to just keep repeating yourself, writing the same thing over and over again. And again, that kind of goes back to this example where if all these properties were the same, we don't just want to keep rewriting them over and over again. So let's go ahead and write actually what I'm talking about. So we're going to create another class and we're going to call it doctor. And this class is going to be an extension of the worker class. And to do that, we're going to put a colon and we're going to put worker and we'll put our braces here. So as of right now, a doctor class is essentially the same thing as a worker class. But it gets, well, by doing this, you're giving the doctor class access to everything that the worker class has. So if we created, let's say instead of, let's say instead of Cole being a worker, he was a doctor. Well, we can initialize it the same exact way that we did the other one, and it will work the same exact way. It's got access to Cole.name. It's got access to Cole.job, job title and job description. And it's got access to Cole.salary. And also it's got access to that Cole.greeting function. So if we run that, we're going to see that this is essentially the same thing as the worker class as of right now. So it gets access again to all of these different properties. It's just an extension of this class. So that being said, it can also have its own properties that maybe the worker class doesn't have, or its own functions that the worker class doesn't have. But before we get into that, I kind of want to talk about what we were just talking about the whole don't repeat yourself thing. So what we're going to do before we start setting all these unique properties and all these unique functions is we're going to create an initializer for the doctor class. So let's go ahead and start by doing the same thing that we did before. And we'll put init. And to initialize the doctor class, we also need to initialize the superclass, is what we call it, which is the worker class. So the worker class obviously needs the name property, the job, the description, and the salary. So we have to set those. Those cannot just be empty. We definitely didn't define those as nullable or optional like we talked about a couple lessons ago. So these have to be set on the class. There's no option not to. But since we're defining the doctor class, we already know what the job title is going to be. We already know what the job description is going to be, and we already know what the salary is going to be, right? Let's say that we're making software for this office, and we already know all of that. The only thing that we don't know about a doctor is their name, possibly. So let's put the name is of type string, and then what we can do, this is where things get really cool. We can call super.init. Super is the superclass, which is worker, and we can say name is name, job title is doctor, right? We could just go ahead and just add this in right here, just directly as a string. We don't need, whenever you're initializing a doctor, we don't need the programmer to pass in the job title because we already know it. We're initializing a doctor class. It's obviously the job title is a doctor. And the job description is to heal people. We already know that as well because this is a doctor class. And let's say for this example that we know that all doctors are going to have a salary of $200,000 per year. So now this makes things really, really cool because I don't need any of this stuff anymore. Now all I need to do is pass in the name, and all of these properties are automatically set, and I automatically get access to this function. So if we run that, we're going to see over here that Cole James, doctor to heal people, 200,000, and the sentence obviously came out properly. So let's go ahead and pause real quick and let's just recap everything that's going on, because this is probably a lot to take in right now. Classes can be a little bit tough to get your grasp around at first. So basically we created a worker class. This is kind of what we call like the base class. This is the lowest level of the class possible. It's the most, let's call it, generic thing that we've got. The worker is just the most generic thing that we need to know about. And a worker has a name, they have a job title, they have a description, and they have a salary. And to set those, we need to create an initializer. And the initializer needs a name, it needs a job title, description, and a salary so that we can set all of these properties right here. And inside the initializer, that's where we actually set the properties of the class. So we're going to say self.name, which is this, equals the name that we passed in to the initializer. And then the same for all the other properties. Self.jobtitle, which is this right here, equals the value that we passed in here, and so on and so forth. So that gives us access to a basic worker class. And a worker knows how to say a greeting, and that just means that it's going to print out this interpolated string right here. So we got that. Hopefully this part is making sense. Now the subclasses, or this is that term inheritance. And we refer to this, instead of a base class, we refer to this as a subclass because it's a subordinate, let's say, or it's a subclass of the base class. So it needs to set all of the properties that are in the super or base class. And so anyways, these subclasses can have their own unique initializers, but you always have to call the super initializer of the base class, which is this right here. It's a lot of terms, but just try to start connecting these pieces together. So by calling that super.initializer, we're going to pass in the name that we provided in our doctor initializer, but we already know all of the things that the worker class needs to know about just by the fact that this is a doctor. So we're just going to say this is a doctor, the job description is to heal people, and the salary is 200,000. So now that we've got both of these classes, right here we initialize a worker class, and right here we initialize a doctor class. And lastly, the doctor, like we said, has access to every property that's in the worker class because we extended it, the worker class right here. So it's got access to all that stuff that we had. Now let's go ahead and step things up just a little bit more. Let's say that a doctor needs to have its own function, and its function is heal, let's say. And for now, let's just say that all that healing does is it prints, I am healing people. Okay, so instead of this greeting where we're just going to print some statement, if we call the heal function, it's going to print I am healing people. Now, let's not forget, I'm just going to keep saying this over and over again. The doctor is a subclass. So this heal function only exists on the doctor class. It will not exist on the worker class. Remember, the worker class is the base class. It's the most generic version of the thing that we're trying to create. So any of the subclasses have access to all that generic information, but they can also have more specific functions that are tailored to that particular thing. So remember that the person class, the worker that we initialized here is a worker class. And since we put heal in the doctor class, we're not going to be able to call the heal function here. Xcode's going to complain here, and it's going to say worker has no member heal. Again, that's in the doctor class, not in the base class. So we're going to have to get rid of that. A regular worker is not going to be able to heal. But Cole down here is a doctor. So if we call Cole.heal, he definitely can do that. And if we print that, we're going to... Oh, sorry, I was looking over here for a second. See, I'm looking like an idiot here too. No, so I was looking right here thinking it was going to say the text, but no, we're looking down here in the console. So he did say, I am healing people. So that's cool. So that's the extended functionality that the doctor gets. And we could create a couple of these. Let's create another one. Let's create a class and let's call it software engineer. And he's also going to extend the worker class. And we'll give him an initializer. Oh, whoops, I hit the wrong thing. And he's going to need the same thing. He's just going to need a name because we know everything else about him. We know that he is a software engineer. So if we call the super.initializer, we're going to set the name in the initializer to the name that was passed into this initializer. And the job title is going to be software engineer. The job description is going to be to write code. And the salary is going to be, let's say, $120,000 a year. So now if we come back down here and we create another variable and we call it dev and we set it equal to software engineer and we initialize that class with the name of Bill Thomas. It's kind of first two names. It's kind of weird. And we run that. Then we've got the software engineer over here, and he's got access to all of the other stuff. So let's do job title, dev.name, dev.job description, and dev.salary. And if we run that, hopefully this is starting to make sense now. We're going to see all of those properties, 3 of which we automatically just set here in the initializer. So we've got one base class now, which is the worker class, and we've got 2 subclasses that can do their own things. And for the software engineer, we'll go ahead and add a function called write some code. And this will just print I am writing code. Cool. Now, let's just go ahead and reiterate something that I was talking about with the doctor. So the doctor is a subclass of the worker class, but he only has access to what's in the base class and in his own class. He's not going to, for example, have access to the write some code function because that's unique to the software engineer. Even though they're both extensions of the worker class, nothing in these 2 classes is shared except for the base class. So write some code is unique to the software engineer and heal is unique to the doctor. And we could see that by coming down here and writing write some code. It obviously doesn't exist and it's going to complain about that. Whoops. But the moment we come down here and we say dev.write some code, he's all over it, but he also doesn't know how to heal. It's going to say, I don't know what that is. You can't do that. And if we run that, we can see that the dev is writing some code. Okay, now let's do one more thing before we wrap this lesson up. And let's talk about extending this one step further. So yes, we can have a base class, and yes, we can have a subclass, but we can also have a subclass of a subclass, and we can extend the doctor even further. So we're going to create a specialist class. More specifically, let's create a, let's say it's a foot specialist. We're going to create a foot specialist class, and that's going to extend the doctor class. So let's go ahead and kind of think, where are we at right now? So with the foot specialist extending the doctor, and not writing any code in here, he's essentially just the same thing as a doctor at this moment, just with his own class name. So we could actually come down here and we could say var foot specialist, or we'll just call him specialist, equals foot specialist. Oops. And he's got access to the same initializer as the doctor as of right now. So if we just started by saying Tim McThompson, did I spell that right? Thompson, Tim McThompson. That's not even a real name. Why am I even trying to spell it right? Anyway, so if we do that and we start accessing his properties, we're going to notice that since we haven't really given him any additional functionality, specialist dot job title. Since we haven't given him any special functionality, we can expect to see the same thing that we're going to see with a doctor. So if we go ahead and run it, his name is Tim McThompson. He's a doctor. His job is to heal people, and his salary is $200,000. Let's go ahead and say for now that that's all correct. That's all good. He is a doctor. His job is still to heal people, and his salary is still $200,000. He just happens to be a specialist. So as a specialist, he needs access to certain, let's say, functions that the doctor didn't necessarily, have access to. So he can have a function, heal foot, let's say. And that's just going to print, I am healing your foot, right? And if we come down here, here's what's cool. So the specialist, being an extension of the doctor class, he has access to the heal function, just like the doctor does, but he also has access to the heal foot function because he's an extension of the doctor class. Because he's just he's his own subclass, and we gave him that functionality. So now he's able to say, I am healing your foot. Cool. Now, last thing before we wrap up this video, in addition to functions, these subclasses can also have their own properties. So if he had a property that the other ones didn't have, it could maybe be like, let's say the foot specialist needs a property called years worked. Maybe that's important to foot specialists. And maybe that's an integer. Well, now it's saying it doesn't have any initializers because we need a way to set the years worked variable. So we can create a new initializer. And this can have a name, let's say. And it can also have a years worked property, which is an integer. And now we're going to say self.yearsWorked equals years worked. And then we're going to call the super initializer, and we're going to pass in the name. So this is where it might be getting a little bit confusing. That was a lot all at once. But basically what's happening is to initialize a foot specialist, the only thing that he has that's unique to the doctor is the number of years worked. So we're going to need his name so that we can pass it to the super initializer, which is right here. And then we're also going to need the years worked so that we can set that here. So this is kind of just a cool part of programming, is that, we can set the properties that are unique to this subclass, and then we can just hand off everything else to the superclass's initializer. That's really neat. So now, instead of initializing this guy this way, we're also going to need to pass in the years worked, and we could say he's been doing this for 20 years. And now the specialist has access to this one last property called years worked. And if we run that, we're going to see right here that he's got 20 years under his belt. And again, no other class is going to have access to that. So, whoops, I don't even know how to spell my name. Col.yearsWorked doesn't exist because this is the superclass, not the subclass. So that kind of wraps it up for this video. Go ahead and just really dive into this code. Go ahead and just really take a look at it. I know that sometimes that can be a little bit frustrating whenever you're learning, but that's just the reality of this job, is you're just going to have to keep analyzing code, keep writing it, really look at what's going on. Notice the patterns. That's really what programming is at the end of the day. It's just a bunch of patterns. So keep looking at this. Maybe keep making your own subclasses. Make some subclasses of a software engineer maybe, right? We've got a software engineer. Let's maybe make an iOS engineer and give him some cool properties and functions. I hope you do that. But regardless, I'm going to see you in the next video, so we'll hop on over.